The MiG-21 was the first successful Soviet aircraft combining fighter and interceptor characteristics into a single aircraft. Designed in the 1950s, its basic layout was used for numerous other Soviet designs. The MiG-21 broke a number of aviation records for its time and is the most produced supersonic jet aircraft in aviation history. MiG-21 still serves many nations a half-century after its maiden flight. It was a relatively light fighter weighing almost 9 tons, while its Western antagonist F-4 Phantom II weighs 26 tons. MiG achieved speed Mach 2 with a relatively low-powered afterburning turbojet. Like many aircraft designed as interceptors, the MiG-21 has a short range. The MiG-21 bis 75AP, MiG-21 bis изделие 75 was the ultimate development of the MiG-21 for the Soviet Air Defense Force. The aircraft is an all-metal cantilever mid-wing monoplane featuring a delta wing, swept-back tail unit and controllable stabilizer. It's fitted with instruments and electronic equipment, ensuring safe flights by day and at night under fair and bad weather conditions. The MiG-21 bis aircraft was designed as a frontline tactical interceptor fighter powered by one turbojet engine. Although primarily designed as an interceptor with the task of destroying strategic bombers, the bis quickly became a multi-role combat aircraft. MiG-21 is one pilot aircraft, and once you enter it with 256 different switches, buttons and knobs, you notice that this cockpit is not a glider or your typical Cessna. Let's begin with aircraft power plant and its controls. MiG-21 bis is equipped with one turbojet engine Tumansky R-25-300 provided with second emergency afterburner stage. The engine RPM indicator is a self-contained system that uses engine rotation to generate power and calculate the needle's position. It has a 0 to 110% scale, indicating the current percentage of maximum allowed engine rotations per minute. Two needles show current engine RPM state, whereas RPM 1 is a low pressure compressor and RPM 2 high pressure compressor. The difference in rotations between low and high compressors is normal, and it decreases with an increase of overall RPM. Usually RPM 2 is higher than RPM 1, but RPM 1 is used to set appropriate engine state. The engine exhaust temperature indicator indicates exhaust temperature in Celsius degrees. Normal temperatures are up to 780 Celsius and up to 850 Celsius with afterburner. However, these extremes are rarely achieved, and the in-flight temperature usually reaches 740 degrees on afterburner. The fuel quantity indicator indirectly shows overall remaining fuel states in liters. During pre-flight setup, initial fuel quantity is set with a knob, and this leftover quantity will reduce based on engine power output, or in other words, based on fuel consumption. Certain warning lights are also used to judge about the amount of fuel left. Wing fuel tanks empty, central fuel tank empty, first group fuel tanks empty, 450 liters left, third group tanks empty, fifth tank empty. Hydro pressure gauges indicate pressure in both main and command hydro systems. Main hydro system provides hydraulic pressure for different aircraft systems, and in the case of command hydro system failure, it provides the operation of aileron boosters. The command hydro system provides pressure for one hydro booster chamber of the horizontal tail and ailerons boosters. If the pressure drops below allowable limit, a warning light on T10 will warn the pilot to pay attention to that particular hydro system. Voltmeter displays voltage level in the DC system. The engine oil pressure gauge displays the current engine oil pressure. The engine low oil pressure warning light will illuminate if the engine oil pressure drops below allowable norm or if metal particles are detected in the engine oil. The pilot has an oxygen mask, G-suit and controller helmet heating. Lighting options are represented by instrument lighting, red flood lights and white flood lights. In the worst case scenario, if an aircraft becomes uncontrollable, the pilot must eject by pulling a lever near the control column. Once airborne, aircraft landing gear can be hydraulically retracted or extended by pulling the lever on the left. If the gear gets stuck, the pilot will see a warning over here, and to lower the gear, pilot will have to rotate the emergency pneumatic extension valve over his right for main wheels, and for nose wheel emergency extension is located in the middle. Aircraft landings can be assisted by extending drag chute from its tail when pressing this button. Don't worry if you accidentally release drag chute mid-flight, it can be jettisoned over here. Flaps control panel is used to operate and indirectly indicates position of the flaps. This button retracts the flaps. Flaps control buttons set the flaps for takeoff or landing positions. Spring release button sets all control buttons to upward position, for example when the aircraft is not in use. In Russian fighter aircraft, all electrical bus switches are separated by welded metal rings to avoid accidental switch activation. This is a very interesting cockpit characteristic that is not found in Western aircraft. On the very right, you can find circuit breakers that prevent short circuiting. Just like in any aircraft, before takeoff make sure no buttons are popped out. Radio station control panel holds 20 preset radio communication channels, which can be selected by rotating the cross-shape selector. Switch selects the audio source, it being either a radio station only or together with NDB station simultaneously. On the right, you have a noise cancellation switch. When turned off, increase capabilities of radio. The panel is turned on with this switch. When in the down position, radio serves as intercom station for communication with ground crew. Here we have the RC main control panel. It holds 9 preset NDB station frequencies. This switch is used to hear station identifiers in Morse code. RC sound can be controlled with this knob. In an emergency, the RC can be used as voice radio station receiver by switching operating mode from compass to antenna. However, the pilot will not be able to transmit any signal. In the RSBN and PRMG control panel, we have channel selection knobs for RSBN and PRMG systems. When appropriate navigation and landing signals are acquired, information lights illuminate. Knob on the left controls station Morse code volume. Let's move on to flight controls. Flight is controlled by rudder pedals and a multifunctional control column that sticks out between the pilot's legs. On the column you can find pitch trim and 2 buttons below it for autopilot. Right button engage recovery mode, which will try to recover aircraft from any attitude to level flight. And the left button disengage autopilot. Rest AP functions are controlled in the AFCS control panel. You can select either autopilot directional landing mode or automatic landing mode, which accordingly activate directional landing, during which the pilot has full control but is provided with landing tips from KPP Yellow Needle or automatic ILS landing. This button disengages formerly mentioned modes. You can press this to activate autopilot stabilization that will dampen aircraft vibrations and stabilize attitude using the trimmer if the stick is relieved. AP low altitude mode switch is used to activate and deactivate the low altitude recovery mode. Whenever the outside temperature is around or below 0 degrees Celsius at any altitude, the pilot should turn on the pitot tube heater. Although the MiG-21 BIS pitot installation is not prone to freezing due to speed dynamic heating, air friction heating effect, freezing might still happen. Indicated airspeed is shown in this gauge. It has one needle that points in scale from 0 to 10 in hundreds of kilometers per hour. When airspeed exceeds 1000 kilometers per hour, needle will make a full revolution and digit 1 will be displayed in gauge. The barometric altimeter works as all typical altimeters, except it shows altitude in C units. Fat short needle points kilometers, and the long thin needle points hundreds of meters. Barometric pressure can be set here in millimeters of mercury. The DA200 indicator, often referred as variometer, combines torque coordinator and vertical speed indicator. White arrow gives precise vertical velocity values up to 20 meters per second and only rough value above that. Yellow pendulum shows turn rate and the slip ball indicates slip. This is Mach and true airspeed indicator, and below it there is a clock. In the place of the artificial horizon you have Russian attitude directional indicator KPP-1 that shows airplane's pitch and bank relative to the stationary horizon. The ADI also has another slip indicator and holds the RSBN or PRMG directional and glide slope needles. The core system NPP is a complex instrument showing current magnetic heading, direction to a selected NDB or RSBN station, desired course or radial, correct reception of localizer and glide slope signals, aircraft position in reference to a localizer and glide slope signals, relative angles necessary for landing pattern creation and relative course system. Radio altimeter shows the altitude above ground up to 600 meters. Altitude is being measured directly below the aircraft, ignoring banks and pitches up to 20 degrees. The accelerometer shows current and maximum minimum G load achieved during flight. This is a very important instrument, especially if the aircraft has external loads and G-force needs to be controlled to avoid the load, for example bombs accidentally falling off, possibly damaging the airframe or other plates in formation, or causing damage to civilian infrastructure or people. Since MiG-21 has delta wing of area of 23 square meters, it keeps great responsiveness at great airspeeds. However, if you deviate too much from allowable angle of attack shown on AOA indicator, the plane will depart stable flight and roll will become uncontrollable. RAU controls the ratio between stick pitch and horizontal tail movement, combining airspeed and altitude in a complex way. Therefore, this gauge shows the current position of the RAU arm, transpositioned to a speed and altitude scale that serve to provide information whether the RAU is functioning as expected. Although usually operated in auto mode, the RAU can also be switched to a manual control. UPRIE S3 shows the current nose cone position in percents of maximum extended position. In case of failure of the auto control system, the pilot can switch to a manual by using the nose cone control switch. A particular nose cone position is set by using a knob and moving the black needle, as the white needle will follow, indicating that the nose cone is changing position.
In this next section, we will quickly go through weapon employment in MiG-21 bis. When talking about air-to-air missiles, there are two types of guidance, infrared and radar guidance. To use infrared missiles, I will make sure that mode switch is switched to air, guidance switch is switched to IR, and station selector is pointing at station 3. To use radar-guided missiles, we will use same configuration, except this switch will be switched to radar guidance. We will also need to lock our target with radar. Let's switch to air-to-ground weapons. To use bombs on MiG-21 bis, I'll make sure that mode switch is switched to ground, missile guidance switch is selected to neutral, station selector is pointing at stations 1, 2, and gunsight mode switch is switched to bombing. To use unguided rockets, we'll use same configuration except gunsight mode switch and station selector, with which we will choose a salvo of 4 rockets.
To conclude, the MiG-21 is an iconic and great performing plane. True is that the most of the MiG-21 bis longevity is due to the fact that it was quite a robust, modest and resilient machine, capable of performing most mission types with minimal maintenance request and with long mean time between failures. However, built as a generic interceptor, it couldn't excel in reconnaissance missions and could never compete with aircraft specially built for air-to-ground tasks.